let's talk about adding or subtracting measurements. And so as mentioned in the previous previous video, our measurements can only be as accurate as the tool we use to obtain them. And that has implications for when we add them together, especially if one of our measurements is less accurate than the other. We want to make sure that we're not taking any error and following and then bringing that through into our answer and getting the impression that we know more than we do. So let's take an example of a car here at point A, and let's say that it travels 13.1 kilometers to point B. Maybe the driver stops for a nap, and then it drives for another 1.28 kilometers from point B to C. And so a couple things here. If we look at these measurements, 13.1 kilometers from A to B, and from B to C we have 1.28 kilometers. So our measurement from B to C is actually more precise. So we have one measurement that is more precise, so 0.28 versus the 0.1. So here's our knowns and our unknowns. So our distance from A to B is 13.1 kilometers. Our distance from B to C is 1.28 kilometers. And we're looking for the total distance, the total displacement here from A to C. So what we're going to do is we're going to add up those first two measurements. So let's do that. Let's head over and let's add them up. So we have 13.1. And now once again, we have to remember that that's not the same as 13.10. We don't know what the second decimal place value is. It could be a 0, it could be a 9. We really have no idea. So instead of leaving it blank, I'm actually going to throw a question mark in there. And we're going to line this up with, line up the decimal points, and we're going to say we're going to add 1.28 to that. Now I'm going to throw a 0 out front just to show you that we actually do know what that value is. We know the values in front of a number are zeros going up, to infinity. It's just they're not necessary to add, so we don't add them. But there is a difference between the value at the front of a number and the value at the end. The front, we always know there's zeros. Behind, we have no idea what that is. So let's just add this up in the same way that we would in elementary school. And we're going to start with on the right-hand side. So we're going to go question mark plus 8. Do we know what that is? So if the question mark is 0, then we would have 8, but we don't know that it's 0. What if it's 8? If question mark is 8, we have 16, and then we need to carry the 1, and we have a 6 in that place. So I will tentatively throw an 8 in there, but I am not confident that that is an 8. I'm not confident at all that that is an 8. And in fact, if that is a really high number, like something that is gonna carry over to the next number, it might even affect that at the 10th level. So we're just going to throw an 8 in there. I'm going to make it red just to remind us we are not confident with it. Then we're going to go 1 plus 2. Well, that's pretty easy. That's 3. We've got our decimal point, and we got 3 plus 1. That's 4. And then we've got our 1 plus 0. That's 1. And so we have an answer of 14.38. But remember, we are not confident with that 8. And because we are not confident of its value, it is not significant to us. The best we can say is that the car traveled 14.4 kilometers. So we can use that 8. We can round up that 3 there. So we're rounding up to 3 significant digits. And that would really be the best we could say, 14.4 kilometers. We cannot say 14.38 because we are not confident in that 8 because we don't know what that number behind the 13.1 is. So 14.4 is best we can do. So when we add or subtract, your final answer cannot be more precise than your least precise measurement. I'll say that again. Your final answer cannot be more precise than your least precise measurement. And so if we go back up here, we've got 13.1, so that's to the 10th decimal place, and we have 1.28, so that's to the 100th. Our 100th is more accurate, our 10th is least accurate. So we can only have an answer to the same decimal place as our least precise measurement. So it means that we can't go beyond that 10th position. So 14.3, we're going to use that fuzzy 8 to round up to 14.4, and that is as good as we can do. That is our answer. So when it comes to significant digits, when adding or subtracting, your final answer cannot be more precise than your least precise measurement.